We now continue with example 3. In this example, again we are given a upper triangle matrix, and then as we remember, the diagonal elements are the eigenvalues. So very quickly we could form A minus lambda I and observe that the product of the product of these elements along the diagonal is this, which is the determinant of A minus lambda I, directly showing us that 5, 3, 5, and 1 are the eigenvalues. We can then write the characteristic equation very quickly, collecting 5 minus lambda to be squared because there are 2 eigenvalues that is equals to 5. 3 minus lambda as well as 1 minus lambda. Now, that 2 there, power of 2, shows us that the eigenvalue 5 has occurred twice in this characteristic equation, and we call this phenomena multiplicity. The eigenvalue 5 has multiplicity 2, or in other words, is repeated twice. And this is called the algebraic multiplicity of the eigenvalue lambda. The word algebraic occurs because we are dealing with this polynomial, and this is eigenvalue repeated twice is reviewed from this equation. Later on, we will also encounter something called geometric multiplicity of the eigenvector, and we'll tackle this then. So in this slide, we introduced a new term, something called algebraic multiplicity of the eigenvalue, which is used to indicate the number of times this eigenvalue repeats in the characteristic equation. Now, let's continue with another example. In this example, the matrix A is a 6 by 6 matrix, and the characteristic polynomial is given to us, and then it asks us to find the eigenvalues and their multiplicity. So something interesting, if we have a n by n, the highest power is n. And in a polynomial with n degree, there will be n roots. And the n roots can be real values or complex value, but there will be n roots. That is the fundamental theorem of algebra. Right, so once we have the characteristic polynomial, to find the eigenvalue, the idea of course then is simply to factor it out such that we can see the factorization, so that now when we have this factorization, for example, if we substitute lambda equals to 6, then this term becomes 0 and the whole characteristic polynomial equals to 0. So we realize that lambda equals to 6 is an eigenvalue, lambda equals to minus 2 is an eigenvalue, and lambda equals to 0 are also eigenvalue. Now talk about multiplicity. Lambda to the power of 4, it also means lambda minus 0, 4. It also means that lambda equals to 0 is an eigenvalue and is repeated 4 times. So the multiplicity of eigenvalue equals to 0 is 4. The multiplicity eigenvalue equals to 6 is only 1. Lambda equals to minus 2 is only 1. Okay, so this is a practice of multiplicity and getting the eigenvalues from the characteristic polynomial. Alright, let's turn our attention to the right hand side now. The solutions of the eigenvalue is sometimes also called the spectrum of A. Okay, so when we say find the spectrum of A, we're actually asking you to find the eigenvalues of A. The characteristic polynomial can be factored in this form. So if we have the characteristic polynomial, then to find the eigenvalues, normally we factor in this so that we can identify that lambda equals to lambda 1, lambda equals to lambda 2, lambda equals to lambda and lambda, and the power here will tell us the multiplicity. Okay, what you'll realize is that if you add up all this power, you'll be equals to n, where n is the n by n matrix, the dimension of the n by n matrix A. Okay, so if you look back at the previous example, the multiplicity is 4, 1, and 1. The sum is 6, and this 6 is the same n by n, the n equals to 6 here. Okay, right. Later on in another few slides, we'll talk about eigenspace. So we'll wait for a while before we reach there. Now for practices, I would suggest you look at Patrick GMT. This is the link for simple work examples of 2x2 matrices. You can also look at strength, introducing the eigenvalue eigenvector problem. And then for interesting understanding with a lot of pictures, then I would suggest 3 Blue 1 Brown, talking about eigenvalue and eigenvector, the perspective. There are also Chesnov from teaching in Hong Kong. He also have a very good series. Again, he go through very quickly the eigenvalue problem and the characteristic equation and the characteristic polynomial. Same with Brunton's lecture, eigenvalue as well. Okay, so these are excellent resources which you can use. Thank you.